Today we're going to be adding and subtracting mixed numbers with unlike denominators. We're going to start our examples with two subtraction problems. The first one here will not require us to borrow, but the second one will. As we go through these, we want to review our steps, and I'd like you to try to stay ahead of me in your mind, be predicting what I'm going to say next. So here's our first problem. The first step is to rewrite the problem standing up. We've already done that. The second step is to take a look at your denominators and see if they are the same. We cannot proceed with any subtraction or addition if the denominators are not the same. Since these denominators are not the same, we need to find our strategy and how we're going to find a common denominator. I've given you two strategies to start with. The very first one would be to look at the largest denominator and ask yourself, if I used 8 as a common denominator, would there be a number I can multiply to 4 to get 8? The answer to that question is yes. There is a number I can multiply to 4 to get 8, so I'm going to use 8 as my common denominator. The top fraction now is going to be very simple because we're multiplying by 1, obviously. The fraction will remain the same. If we have the same denominator, then the numerator will have to remain the same. On the bottom fraction, we're looking for our multiplier. 4 times some number equals 8. That number would be 2. And we will do the same thing to the top part of that fraction. Our numerator, 1 times 2, will get us 2. Now we have two fractions with the same number of pieces that it takes to make a whole, 8. Our numerators are okay, and we can now subtract. 3 minus 2 does not require us to borrow. So 3 minus 2 is 1. The denominator stays the same. We cannot forget our whole numbers. We'll be subtracting 2 minus 1 to get 1. We aren't exactly finished yet. We need to always check our fraction, make sure that A, it's not improper. This is not an improper fraction. And B, it can't be simplified. If it can be simplified, we want to do it. So in order to see if you need to simplify this fraction, you'd have to ask yourself if there is a number that you could divide both the top and the bottom by to make these numbers smaller. Because the numerator is a 1, it can't get any smaller than that. When you have a numerator of 1, your fraction is simplified. So there will be no number, and 1 1/8 will remain our final answer. On to our next problem now. This one I'm going to work through with you as well. This will require borrowing. As we go through this problem, again, we're going to go through the steps. Step 1 is to rewrite the problem. That has been accomplished. Step 2 is to check your denominators. 5 and 4, they are not the same. And so continuing with step 2, we're looking to find a common denominator. Again, the first trick would be to look at the largest denominator and see if there's a multiple. If we use 5 as our denominator, is there a multiple that we could use with 4 to get 5? The answer, of course, is no. So the second strategy that I taught you in order to find a common denominator would be to simply multiply your two existing denominators. So multiplying 5 times 4 will get you 20, and that will always work as a common denominator. You should never be staring at it for too long. You always know you could just multiply your two denominators. Is this our smallest possible denominator that both 4 and 5 would share? Well, it happens to be. And if you happen to ever find a smaller number that you could use as a common denominator, you should use it. It will save you time later when it's time to simplify. Now that we have our common denominator, one of the nice things about using these two denominators to find it is that we know our multiples. 5 times 4 is how we got 20. 2 times 4 is 8. 4 times 5 is how we got 20. 1 times 5 is 5. We're on to step 3 now, where we're going to be subtracting, taking a look at the sign. We're going to be subtracting 5 minus 8. And once you realize that you cannot subtract 5 minus 8, then you realize that you're going to have to borrow. And let's recall how we borrow. To borrow, we always take from the ones place in the whole numbers, and here we only have one whole number. So we're going to take from the 5 and turn it into a 4. We have to remember that we're taking 1. And we can't just put that 1 in front of our 5/20ths because that doesn't help us increase the numerator. We're trying to increase the 5 on this numerator so that it is larger than the 8. Putting a 1 in front of this fraction turns this into 1 and 5/20ths. It turns it into a mixed number, and it doesn't change our numerator, so it doesn't help to do that. Instead, what we must do is add that 1 to the fraction that's here already. And remember that adding 1 is really simply any fraction that has the same numerator as the denominator. And so because we want to add these two fractions, we might as well make the denominator the exact same. There would be no other way I would do that. So we're going to turn our denominator into 20, and since this fraction here has to equal 1, what would the numerator have to be to make this 1? That's right, it would have to be 20 as well. That equals 1. Now we can add our two fractions here, and 5 plus 20 is 25, and the denominator will stay the same. We need it to stay the same because now we have two fractions with the same denominator, and our top fraction is 25 now. So now we can subtract 25 minus 8. All of these fractions over here are now meaningless to us. We don't need them anymore. Even this fraction here is now meaningless to us. We have our two fractions that we need to subtract now. So in doing so, we're going to subtract 25 minus 8, and we get 17. Our denominator will stay the same. We subtract our whole numbers, 4 minus 2, and we will get 2. That would be our fourth step. Now our fifth step would be to check our fraction, see if it is improper. It's likely not going to be improper since we're subtracting and making less. The second thing you need to ask is, can I simplify it? Is there some number I could divide both 17 and 20 by? If it's not obvious what you could divide them by, take a look at your smallest number in this fraction, 17, and find the multiples of 17. You could multiply 1 times 17 to get 17, and are there any other numbers you could multiply to get 17? There are not. And that makes this number a special kind of number. We call that number prime. And once you have a prime number in your fraction, it's unlikely you could simplify it unless 17 will go into 20, and it will not evenly. So therefore, our final answer is right here, 2 and 17/20. Now I would like you to pause the video and attempt to solve this problem on your own. Come back to the video and I will walk you through it, and you can see how well you've done. Welcome back. Step 1 is done for you. Step 2, I hope you looked for common denominators and realized that they were not the same already and that you would have to find your own common denominator. If you looked at the number 5, you would see that 3 will not go into 5 evenly. There's no number to multiply to 3 to get 5, so that will not work for you. So you most likely had to look to the two denominators you have already and multiply them. If you did that, then you got 15. That would be a great common denominator. Now we will find our multiples, which will be easy to find because we multiplied by 5 here and by 3 here. We'll do the same thing to the top, and you should be looking at your work, making sure that you had 6/15 and 5/15. You would then subtract your new fractions, realizing that these fractions are no longer needed. 6 minus 5 would have gotten you 1, and 15 would stay the same. Then you would subtract your whole numbers, 4 minus 2, to get 2. You would then have checked your fraction to see if it was improper, realizing that when you're subtracting, it's likely not going to be improper. But you would also check it to see if you could simplify, and realizing that your numerator is a 1, you would know right away this cannot be simplified. So therefore, this should be your final answer. We're now going to switch over to another subtraction problem. This one will be with borrowing. If you need to, please rewind this video so you can watch the example again on how to borrow. Pause the video now. Welcome back. Now our first step is done for us. Our second step would be to look at our denominators. We have a 4 and an 8. We look at the largest denominators since they are not the same already. We'll want to try to find a common denominator, so we're looking at the 8 to see if that would be possible. Hopefully you discovered that was possible. 8 would be your best denominator. If you did use 32, then you would have some work to do after you're finished with the problem. You would need to do some simplifying. Since I'm going to use 8, my multiple here will be 2, and that would have gotten 6 eighths, and here would remain the same. Now we're looking to subtract. Our problem here is that we are trying to subtract 1 minus 6. That cannot be done. You must be aware of the possibility that you might have to borrow. You should be looking for that possibility each and every time you see a subtraction problem. Don't be afraid. And please don't just revert to subtracting the top number from the bottom number. You can't do 6 minus 1. So we must borrow in this situation. We were prepared for that. So we're going to cross out the 7 and make it a 6. I hope that you've done that already. And then I hope that you would have added the one that you borrowed to the fraction that already exists. That you would create a fraction that equals 1 to represent the one that you borrowed, and make that fraction with a denominator of 8 so we can easily add these two fractions together. And since the bottom number is 8, the top number is going to be 8 as well. And now we can add our two fractions and we would get 9 over 8. 9 over 8 is an improper fraction, but that's what we were looking to get. We needed to increase our numerator so we could subtract the bottom one. And so we created an improper fraction on purpose so that we can subtract. Now we can look at these older fractions as nothing more than clutter. We actually don't need any of that stuff. And we're focused now on our two fractions that we need to subtract. 9 eighths minus 6 eighths, which will get you 3 eighths. And then we go to our whole number, 6 minus 2, which is 4. We have two steps remaining. One is to check for improper fractions. 3 eighths is not improper. It takes 8 to make a whole, and we only have 3. The second thing to look for is a way to simplify. 3 is already a very low number, and 3 is what we call a prime number. There are only two numbers you can multiply to get 3. Because 3 is prime, the only thing we could possibly divide these numbers by would be 3. Again, 1 is not an option. We can't divide 8 by 3. That will not work. So therefore, we are already simplified. There's no way to simplify anymore. This was your final answer. Congratulations if you got it right. The final example I'm going to walk you through is adding mixed numbers. Actually quite easier than subtracting with borrowing. We follow the exact same steps. We rewrite the problem standing up. We take a look at our two denominators. Are they the same? If they are, wonderful. If not, we need to find common denominators. These denominators are not the same. We're going to find a common denominator. We, of course, will look at the 4, and we will see if 3 will go into 4. 3 will not go into 4, therefore we cannot use 4. Then we won't spend a lot of time guessing. We're just going to multiply 3 times 4. Multiplying 3 times 4, because they're two small numbers, won't get us too big of a denominator, so it's not a bad tactic. Now we can just find our multiples for each fraction. Our bottom fraction multiple will be 3. That's what we used to find this denominator. And our top one will be 4. Once we do something to the bottom, we do the exact same thing to the top. 2 times 3 is 6, and 2 times 4 is 8. We are adding fractions this time, paying very close attention to our sign all the time. Adding 6 plus 8 is 14. Our denominator stays the same. Adding our whole numbers now, 5 plus 4 gets us 9. Now our final step, our fifth and final step, is to take a look at our fraction and see if it's improper. We know that it's improper if we have more pieces and more pieces is represented on the top number, our numerator. If we have more pieces than it takes to make a whole, then we have an improper fraction. In this case, we do have an improper fraction. How do we fix that? One way to do that is to think of this line as a divide by line, and that is exactly what it is. This can be read as 14 divided by 12. However, you should already know that 12 is very close to 14, and 12 is only going to fit into 14 one time. It can't fit anymore. Once you realize that 12 only goes into 14 one time, you can actually view this fraction now as a subtraction problem. It's already lined up for you, so you could just subtract 4 minus 2 is 2, 1 minus 1 is 0. There are 2 then left over. The 2 that are left over after you create one whole will become your numerator. That's the amount of pieces you still have. The denominator will not change. It will still be 12. Now we've fixed our improper fraction, but we're still not done. We still need to look at our fraction and still have to ask the question, can it be simplified? In this case, we see two even numbers. One big clue you can simplify is when you have both of your numerator and denominators that are even numbers. So once you recognize that, you should just begin simplifying by using 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So our final fraction is 1/6, and I know that that is simplified because the numerator is 1. It won't always be simplified the first time you do it because you won't always choose the best number to divide by. If you don't choose the largest possible number to divide by, you will have to simplify it again. So get into the habit of asking yourself, can I do it again? Our final answer now is our whole number 9 plus our whole number 1, which gets us 10, and our fraction 1/6. Do not forget to add your two whole numbers. Sometimes that gets forgotten. Let's have you try a problem on your own. Please pause the video now, solve this problem, then come back and see how well you did. Welcome back. Let's take a look at how you did. Step 1 is done for you. Step 2, find the common denominator. Are they already common? No, they are not, so we need to find a common denominator. If you used 8 times 6 to find a common denominator, it will work for you. 48 is quite a large denominator. However, there is a smaller common denominator you could have found. In order to find the smaller common denominator, you would have had to take a look at your smallest denominator, 6, and start going through the multiples of 6 with the intent on finding one that 8 would go into. So the first multiple of 6 is 6. 8 won't go into that. 12, 8 will not go into 12. 18, 8 will not go into 18. 24, 8 will go into 24. So I'm just going to show you right next to this problem what would happen if you didn't find the smallest or the best common denominator. All right, so we're going to solve for both of these common denominators so we can see the difference. If we find the multiple for our first set of denominators, which is 48, we used 8 down here and 6 up here. So we'll use 8 here and get 32. We'll use 6 here and get 6. When you add these two together, you would get 38 48ths. That is a fraction that's not improper. However, we can see both the numerator and denominator are even numbers. Therefore, we can divide this by 2 and start simplifying it. Now let's use our simpler common denominator, 24. What would be our multiple to get 24 on our bottom fraction? What would we multiply 6 to get 24? That would be 4. And if we apply that same rule to our numerator, it would be 4 times 4, which is 16. And how would we go from 8 to 24? On our top fraction, that multiple would be times 3. And if we did the same thing to the top, it would be 1 times 3. Using our original fraction, we still have to multiply 1 times our new multiple. We're just pretending that the 48 isn't existing right now. And that would get you 3. Now when we add our fractions, we'll get 19/24. Again, that fraction is not improper. And we also have to look to see if we could simplify it. But 19, although it may not be apparent to you, there are only, if you think about it, 2 numbers you can multiply to get 19. So we call that prime. Because it's a prime number, then the only thing we could divide these by, both top and bottom, would be 19. We wouldn't use 1, so the only one that's available is 19. And 19 will not go into 24, therefore there is no simplifying needed. So our fraction would be actually A-OK right now. That's if we used the smaller common denominator. If we took a few moments to figure out if there was a smaller one than 48, we could have saved ourselves the step of having to simplify at the end. Well, if you used 48 as a common denominator, then you would be stuck with 38 48s, and you would then have to divide. In this case, you would be, the obvious choice to divide by would be 2, because they're both even. If you divide 38 by 2, you have some work ahead of you. You're probably going to have to write that out. But 38 divided by 2 equals 19. And 48 divided by 2 equals 24. So what you see happening is, if you're just going to multiply the two denominators to find a common denominator, it will work, but it may not save you some work. You may end up having to simplify, and you may have large numbers in your numerator and denominator, and you may have to simplify more than one time. Whereas if you've taken a moment and used the trick that I just showed you, writing the multiples up here of your smallest number in your fraction, your smallest denominator, if you'd done that and found 24 to be common as well, you could have made your job a lot easier. Your multiplication would have been easier in the fractions. Your lack of having to simplify would have made it easier. It just makes everything easier. We still have to add our whole numbers 3 plus 2 to get 5. But our final answer now is going to be 5 with our 19/24. If you showed me 5 with 38 48s, I would ask you to simplify. So please take a moment before just multiplying your two denominators to see if you know your math facts well enough to try and find a smaller common multiple. It's not necessary to write them out as I did here. If you know your 6's, you can just rattle them off. 6, 12, 18, 24. And if you know your 8's, you would have recognized 24 as a multiple of 8. A problem on your own. To the second example. Sticking with subtraction, let's take a look at our second example and try to stay ahead of me in your mind as I walk you through this problem. Step number 1, rewrite it. Standing up, that's done. Step number 2, take a look at your denominators. Are they the same? No, they are not. So we need to find new denominators. Our new denominator, I would be looking at the 5 to see if that could be used. If I put a 5 here, would 4 times some number equal 5? Of course, there is no number to multiply to 4 to get 5. So the second thing to check for, one of the easiest things, simplest things you can do to find a common denominator, is to multiply the two denominators you already have. 5 times 4, which will give you a very quick common denominator, 20. Then we're going to multiply